Hi, I'm Stacy Robinson, and I'm going to do my spectral analysis for C6H8O3. So the first thing we're going to do with our formula is the mass spectrum. And before we start, I'll put this up here. The molar mass of our formula is 150, and we can see that number right here, which makes this the molecular ion. We can also see that this is our base peak. It's the tallest peak on the graph. And because they're the same peak, we can't find differences between the molar mass and the base peak, so we won't be able to use our reference table off to the side here. So the next thing we can do with this graph is the degree of unsaturation. So from the formula, we found that there are 6 degrees of unsaturation in this structure, which means we are working with probably both pi bonds and a ring. So the next graph we're going to do is the infrared spectrum. We have our formula still written up here. And we're going to start working with this first peak from left to right. This is in zone 1. And this tells us we can have an alcohol in our structure or an alkene. This one here tells us we probably have an ester in our structure. And then this one here in zone 5 says that we have some sort of alkane in our structure. So the next graph we're going to do is the proton NMR. And from this graph we can make a potential structure and then verify it as we go along. So the first thing we're going to do is find the integration number. And by just adding these up, it's going to find our integration number. We have a 1 here, 3 here, and 2 here. And that is going to give us this 6 hydrogen here. Also, by looking at this graph, I can see that this hydrogen here exchanges, which tells us that we probably do have an alcohol in our structure. This group here, right in between the 6 and 7, tells me that there's probably a benzene ring. So I'm just going to go ahead and draw a structure and try to see if we can figure out what it is for our formula. So we have a structure here, and I can see that we have the alcohol here. So that's going to be one of our hydrogens. 3, 4, 5, and 6. So that checks out with the integration number. We know that this one's going to go over here after this 9 down here. And then I'm going to look at this zoomed in graph down here and redraw the structure. This hydrogen here splits to a doublet here. So that is going to be this hydrogen here, because on the adjacent carbon we have 1 hydrogen, and then using our n+1 rule, the 1 hydrogen plus 1 is 2, so that would be this doublet here. This middle hydrogen here is going to be this middle hydrogen here. And we can see that because it is unclean splitting. So we cannot do the n+1 rule with that one. And then our last hydrogen we're dealing with for this part is this other one on the benzene ring, and that's going to come here. And again, it splits to a doublet. On the adjacent carbons, we only have 1 hydrogen plus 1 is 2, and that's why there is a doublet there. So now we're going to do the carbon NMR. I went ahead and redrew the structure here. And you can see that this area off to the left needs to be zoomed in again. So we'll blow that up here. And the structure is redrawn. So right away I can see that we have a carbon double bond to an oxygen, and that is going to come all the way down field. Next we have a carbon with an alcohol, and that's going to be this one here. Next we can see we have these three here, which are very similar. So we're going to draw these ones that are on the benzene ring. To those three peaks. Now we're going to deal with this carbon, who connects to only other carbons, but also connects closer to the oxygen. So that's going to come up to this peak here. And our last one on this graph is going to be this carbon that is connected to this oxygen. So the only carbon that is left up here is this one here, and this one's just connected to carbons, which are only connected to hydrogens. So it's all the way closer to the right side of this graph.
Okay, that was my spectral analysis for C6H8O3. Thanks for watching.